Hi, I'm Mr. Kangas, and today we're going to be looking at Chapter 3, Section 5, two-step equations. In this video, we're going to be looking at the easy way, as I like to call it, the easy way to solve two-step equations. In the next video, we'll be looking at the harder way, which sometimes is necessary when you're working with slope-intercept form. But today we're just going to discuss the easy way. So two-step equations are very similar to one-step equations. If you have not watched that video and you don't know how to solve one-step equations, you should go look at Chapter 3, Section 3 and Chapter 3, Section 4 on one-step equations. One-step equations require one step to solve for x. Two-step equations require two steps because there are two numbers to get rid of. So to start, we have our problem and we already know what our goal is. We want to know what x is. So you can see our goal is to know what x is, so we know right off the bat we need to get x by itself. So we need to get rid of this 3 and this 2. It takes two steps to get rid of these two numbers. Just as with one-step equations, the way you get rid of numbers is to cancel them out. You do the opposite. So the question is, which number do you start with first, the 3 or the 2? In the easy method, you always want to get rid of the number that's by itself. This is called a constant. Okay, this is a number that's not attached to x. It's called a constant because its value is always the same. No matter where you see the number 3, it's always got a value of 3. The 2x is a variable because its value varies. Depending on the equation you see 2x in, will dictate whether or not what its value is. So 2x's value can change based on the equation. 3 is always equal to 3. So the first number in the easy way that we're going to get rid of is the plus 3 because the 3 is by itself. So just as with a one-step equation, the opposite of plus 3 is minus 3. So we're going to do 2x plus 3 minus 3. And at this point, you also need to input that minus 3 onto the right side of the equation, and the reason for that is because of the equal sign. The equal sign tells you both sides are the same thing. They're not two different things that have the same value, they are the same thing. The left side, as I like to explain it, is Mr. Kangas. The right side is Justin Kangas. If you take $3 from Mr. Kangas, you have to take $3 from Justin Kangas because we're the same person. This is just simply two different ways to represent the same thing, or two different names to represent the same person. Congruence, or the word congruent, that's when you have two different things with the same value. So for example, if you have two congruent shapes, you have two different squares that look exactly the same. Or if you have two different people, such as identical twins, they look exactly the same, but they're different people. In this case, we have two different things representing the same person. So what you do to one side, you have to do to the other because of the equal sign. The equal sign tells you that is mandatory. So the 3's on the left side cancel each other out, and you're left with 2x. 13 minus 3 on the right side becomes 10. Now we're down to a one-step equation. We have to get rid of the 2. Just as with the one-step equations in the previous section, the 2 is being multiplied, so the opposite of that is to divide. So to get rid of the 2 that's being multiplied, we divide by 2. 2 times x will get you to a number, divided by 2 will bring you right back to x. You can put any number in there for x, such as 5. 2 times 5 is 10, divided by 2 is 5. Opposites always undo each other, they cancel each other out. So the dividing by 2 undid the multiplying by 2. And because the equal sign says both sides are the same person, just different names for the same persons, we have to divide by 2 on the right side as well. And find out that x equals 5. And you can always check your answer. If x is 5, we can plug it back into the original equation and see if it works. 2 times 5 is 10, plus 3 is 13. So I'm going to do one more example, just to make sure we have it down. And I'll try to go a little bit slower this time. Okay, just as before, our goal is to get x by itself. So now we need to get rid of the divide by 3 and the plus 4. Again, the easy way is telling us we want to get rid of the number that's by itself. We want to get rid of the constant, in this case the plus 4. The divide by 3 is attached to the x, so we're going to get rid of that last. And if you want to know, you can do it either way, but like I said before, getting rid of the 3 first is the, quote, hard way, and we'll explain that in the next video. So to get rid of a plus 4, you do the opposite, which is subtract 4. You take $4 from Mr. Kangas, you're also taking $4 from Justin Kangas, so we have to do it to both sides. The 4's cancel out. We're left with x over 3 equals 5. At this point we want to get rid of the divide by 3. And the opposite of dividing by 3 is multiplying by 3. And you have to do it to both sides. X equals 15. Okay, and one last example before we end the video. We'll do a negative 3x plus, or we'll do minus 5 equals negative 17. So again, you're going to solve for x, so we need to know what x is. That's our ultimate goal. First number you want to get rid of is the minus 5, because it's by itself. There's no variable attached to it. So the opposite of subtract 5 is add 5. So we're going to do negative 3x minus 5 plus 5 equals negative 17 plus 5. The 5's cancel each other out. Negative 3x equals negative 12. Now if you want a more detailed explanation for why the 5's cancel out, if you take a look at the previous video on one-step equations, I go into much more detail on that. And if you are uncomfortable with adding and subtracting integers or negative numbers, take a look at my chapter 2 videos. There are a bunch of chapter 2 videos on multiplying, dividing, adding, and subtracting with integers. At this point we have negative 3x equals negative 12. We need to get rid of the negative 3 so our x can be alone, because we want to know what x is, not what negative 3x is. So to get rid of negative 3x times, to get rid of negative 3, which is being multiplied by x, we do the opposite. And we divide by negative 3. Very important that you keep the negative, because we want to get rid of the negative 3. And so if you do negative 3 times a number, divided by negative 3. The two negatives cancel out and we end up with a positive x. Okay, to get rid of something, you do the opposite operation. You don't need to do the opposite sign. We were multiplying to begin with, now we're dividing. So those are opposite operations. The sign of the number should stay the same. So for example, if I have negative 3, let's say x was 4. Negative 3 times positive 4 gets you negative 12. Negative 12 divided by negative 3 brings you back to your positive 4, which is where we want to be. If I had made this negative 3 on bottom positive, I would have ended up with negative 4, in other words, negative x, which is not what I'm looking for. Negative 12 divided by negative 3 gets you an answer of positive 4. Again, you can plug that 4 into your equation to check your answer. I'm not going to do that this time. And that is the end of this video. What? Hi, I'm Mr. Kangas, and today we're going to be looking at Chapter 4, Section 6, Negative Exponents. We're going to be discussing three things today. First of all, how do you find the value of a negative exponent? Second, how do you change a number that has a positive exponent into a number with a negative exponent? This is possible. Third, how do you change a number with a negative exponent into a number with a positive exponent? So to start, how do you find the value of a negative exponent? To answer that question, we need to look at positive exponents first. If you take a look at 3 to the second power, we hopefully remember that that means 3 times 3. Then we have 3 to the third power, which means 3 times 3 times 3. So if you take a look as the exponent increased by 1, we added another times 3. Or another way to look at it is as your exponents increase by 1, your answers increase by times 3. So my answer of 3 to the second power is 9. 3 to the third power would be 9 times 3, which is 27. So if I did 3 to the fourth power, I could add a fourth times 3 on the end of this, or I could do 27 times 3. So as we move up an exponent, we multiply by 3. So then the question is, what happens as you move down in exponents? Because in order to get to the negative exponents, we need to move down. We need to go from 3 to 2 to 1 to 0 to negative 1. So if moving forward or up multiplies by 3, moving in the opposite direction will have the opposite effect. So to get from 9 to 27, we multiplied by 3. So to get from 27 to 9, we're dividing by 3. Or in other words, to get from 3 to the third power to 3 to the second power, we just divide by 3. So as your exponents decrease by 1, we will be dividing by 3. The generic way to look at this, or the algebraic way to look at this, is as my exponents decrease by 1, we're dividing by the base. Because depending on what the base is, will depend on what number you're multiplying or dividing as you move up and down. For example, if I go from having a base of 3 to a base of 2, as I go up an exponent, I add a times 2 onto the end, and I end up with 3 2's instead of 2 2's. Before, I was multiplying by 3's because of the base. So now, as I move up one exponent, my answer is being multiplied by 2 instead of 3, because the base is 2. So what happens as we move down? We said that to move down one exponent at a time, you divide by the base. So let's take a look at what happens when we get to the negative exponents. If I am at 2 squared, that equals 2 times 2, which equals 4. When I get down to 2 to the first power, that just equals 2, because 4 divided by 2 is 2. We said to move down one exponent, you need to divide by your base, which in this case is 2. So to go from an exponent of 2 to an exponent of 1, I would divide this 4 by 2, and I'm at 2. The next exponent is 0. So to get the answer for 2 to the 0 power, I take the answer for 2 to the first power and divide it by 2. 2 divided by 2 equals 1. Anything to the first power will be itself. If you recall from previous lessons, I told you if you don't see an exponent, the number has an exponent of 1. So when you see the number 2 on a piece of paper, technically that 2 is to the first power. So any number to the first power is itself. Any number to the 0 power is always 1. Because to get from 2 to the first power to 2 to the 0 power, I have to do 2 divided by 2. If this was 3 to the first power, it would equal 3. And to get to 3 to the 0 power, I would divide 3 by 3 and get 1. So to go from a first power to a 0 power, you're always dividing a number by itself, which will always equal 1. So here comes the part we've been waiting for. The negative exponent. To get 2 to the negative 1, I would take the number 1 and divide it by 2. Which would be 1 over 2. To get 2 to the negative 2, we take 1/2 and divide it by 2. So, there are two ways to divide fractions. You can either go straight across, which is typically not recommended because you'll end up with decimals in your fraction, or you can flip and multiply. I do have an explanation on why flipping and multiplying works, but that is in the fraction video, dividing fractions. So, to flip and multiply, to divide fractions, you flip the fraction on the right, and you change division to multiplication. This does work. This is accurate, and again, there's an explanation for why this works in the fraction section under dividing fractions. And to multiply fractions, you just go straight across. So 1 times 1 is 1, 2 times 2 is 4. So if we take 1/2 and divide it by 2, we get 1/4. So 2 to the negative 2, or 2 to the negative 2 power, is 1/4. Now, if you take a real close look, you're going to notice something special about our negative exponent's answers. More specifically, the number in the bottom of the fraction. Let's take a look at 2 to the first power, which equals 2, and 2 to the negative 1. Which equals 1/2. Now let's take a look at 2 to the second power, which equals 4. And then take a look at 2 to the negative 2, which equals 1/4. If we take a look at 2 to the first power's answer, it's 2. If you take a look at 2 to the negative 1, it's 1/2. The 2 from the first power, from the positive 1 power, is in the denominator of my fraction. The answer to 2 to the second power is also in the denominator of 2 to the negative 2. This is always going to happen because when we divide fractions, like I said, you flip and multiply. So if I wanted to find out what 2 to the negative 3 is, I'm going to take 1/4 and divide it by 2. Now flip the number on the right and multiply. And watch what happens. The top always ends up being 1 times 1 because the answers of the negative exponents always have a 1 on top. And the bottom number, the 4 in this case, always ends up being multiplied by that 2 because the 2 goes from being on top to bottom. So it's just like the positive exponents. You're constantly multiplying that denominator by 2. So you're going to get the same answers in the denominator that you would for the positives. So if we take a look at 2 to the positive 3, that equals 8. So we should get 1/8 for 2 to the negative 3. Let's check it out. Taking 1/4, dividing it by 2, and we get 1/8. So there's a rule that we can come up with here. What happens any number to the negative power is equal to 1 over that number to the positive power. To show you an example of this with numbers, 2 to the second power, or 2 to the negative 2 power, is equal to 1 over 2 to the positive 2. In other words, 1/4, because 2 to the second power equals 4.